This conference will now be recorded.
We are talking about the access modifiers, and then we also have discussed the principles like encapsulation and abstraction. That is also there. Okay, then that's about that part. Then we'll switch to the next topic. Today we will discuss about singleton objects. That is one thing, very important topic. Along with that, we will also discuss companion object. That is also important. And then the next topic, case class, one of the very important topic. And then after that, just anyhow we discuss constructors. Constructor overloading is discussed. Then we'll talk about inheritance. Before going to talk about this one, we'll talk about inheritance. That is one more thing we are going to discuss. Then after that, we'll talk about polymorphism. That will almost end the discussion of this principles of OOP. Then we'll talk about traits. No. He is actually Vijay Srikanth. The Scala person is Vijay. Don't worry. So he is one of my very close student, and he is also a working professional. Clear, right? Now let's get to the topic. Today I would like to talk about these things first, the singleton as well as companion. If time permits, then I will switch to the case class discussion. That is also one more important. Anonymous we have discussed yesterday. We don't have discussed this one more time. Yeah, fine, Srika. Thank you. Correct. But later on, when I just came to know about that. No issues. So, what is a singleton object, and why do we need it? Let's discuss it quickly. So, this is something which is very important. As per the OOP, object-oriented terminology, we can have singleton, double ton, triple ton, quadruton, like that. Then we can have different tons. The concept of singleton is we call something called design patterns in Java. Even design patterns exist in Scala. Design patterns exist in any language that is there. The purpose of design pattern is two things. One, to optimize the code and to reuse the code. So that's why people prefer design patterns, so that it increases the flexibility of coding and reduces the burden on the developer. Also, we have a more better optimized code, and then we have also reusability there. You get it then? So that's why we use all this. All of you are clear now? Now what is that? Then what is singleton here? So when you talk about it, there is something. Let me tell in general terminologies. See, if you search in Google, let's quickly search it. Leave about Scala thing, because excuse me, it's not. Don't worry about my cough. Okay, nowadays if somebody coughs or sneezes, so it's more than having atom bomb. That is the fear it causes people. But this cough is not that cough. You got my point, right? So if you see, these are the patterns, design patterns. Actually, if you look at it, if you just look at it, there is a Wikipedia for that singleton pattern. And when you look at it, it's a design pattern. And if you look, this is a part of software engineering. See, this design patterns or all this, having these interfaces, classes, this all, when you go for software engineering, how you are going to build your things. That's what we call, that's why what software engineering focus. And here, when you look at it, singleton pattern is what? It is a software design pattern. If you look at it clearly, I'm just giving you a quick idea. Okay, that restricts the instantiation of a class to, can you see, single instance, and the very good reason here itself they were giving us, this is useful when exactly one object is needed to coordinate actions across the system. Actions means methods. The terms comes from the mathematical concept of singleton, like unit set. I'm not sure about this. I'm not that good in maths. So what is that unit set? I need to little explore it. But still, this gives you a clear idea about singleton. This is enough for us. Don't go for too much of what is that? This thing, unless and until if you want to do any research or a PhD. Otherwise, sometimes in a software, this thing you need, like, you should be more abstraction. You should apply more abstraction here. Know what is necessary. Rest of the things you leave it aside. That's what the abstraction thing is. It's good for our brain sometimes. Okay, trust me. But sometimes it's good to dig more into the things. That is also good. Let me have this definition here so that people have a good understanding. But I don't need to explain now what is a singleton, because this is very simple and clear. When something is a singleton, at most you can create only one object to such kind of singleton classes or whatever it is, or objects, whatever it is. Okay, and you go for this. Usually it's a kind of pattern where you are allowed to create at most one object. It's a way of making it optimized. Some you are bringing in some restrictions onto the object so that you don't allow users to create multiple objects. So there is a lot of performance and optimization involved here. So that's why this concept of design patterns were introduced. So got it right? We don't need to talk about design pattern more now. It's not necessary, but just remember there are so many patterns in Java. If you go to Java, same patterns are applicable in some. Most of those patterns are applicable in Scala also. You got it right? Even the POSO is a kind of design pattern. I told you, right? We need to talk on that. I told you, if I forget, remind me. After this, I will make you to understand. So, and how do you declare the singleton objects in Scala? If it is Java, you do certain things like if you don't want to allow to create multiple objects, making the object as static will just allow to create only one object. Got it right? That static keyword is useful there. But in Scala, we don't have the concept of static, even though, so we can simulate it. That static keyword is not available, but we can that presence of that thing is there. So then how do you declare singleton objects in Scala then? If you don't have a static keyboard like in Java. In Java, definitely, if you want to go for a singleton object, you need static keyword. But in Scala, there is no such static keyword, static variable, static methods. You don't have all that. But how come we can have static concept in Scala? And that is possible with this singleton objects. And to be honest, we have discussed so far. We have used number of times from the beginning of our Scala. We have used this concept of singleton from the very beginning of Scala. Right? How do you declare it? Singleton object is an object which is declared by using the keyword object instead of class. So that is what this is, right? Is that one or not? And is this test, whatever you create, this test object, is that a singleton or not? I told you somewhere in the very beginning, this object construct is a singleton object. Means for this, you can create at most only one object. Your JVM allows you to create only one object. We cannot have multiple objects. If you try to do that, nothing happens. Still only one object is created. Got it right? So that's the concept of this one. How do you declare means? This is already there. If you use this object keyword and declare something, a construct means that a syntax thing, then by default it becomes a singleton object. Hope this is clear. Got it? And here another important is one more important thing. What is that? Suppose you see here inside this, if I declare a method like this, def m1, okay, something like this. Don't worry, this is part of class and this is part of object. Both are different. This one belongs to object, this one belongs to class. Now here you can print something here saying that howdy. Okay, so that is it. Got it? That is one thing. Second thing, now if it is an instance method which is inside a class, I should call it by creating object like this. But suppose if it is this method inside object, singleton objects, if you have methods, if you have variables, these methods can also be, it's more or like these are global methods. You can assume them as global methods. Suppose if I declare a variable here where some x equal to some 10, you can assume this as a global variable. What is this? Global variable or method means they are accessible anywhere directly without any objects. Got it right? And you have just only one copy of such members. The variable you declare inside this object, the singleton objects, the variables which you declare here. For this, at most one copy exists for these variables. And for this method, at most one method copy exists. Of course, for methods anywhere it is same, but for variables it will be different. Another difference here is if it is part of a class, this becomes instance. Instance variables exist for every object. If you create 10 objects, 10 objects will have 10 copies of A1 and B1 variables. But number of copies of methods are same, nothing to worry. But still, these methods can be accessed only by creating object for this class A. But here it is not the case. What is it then? Let me give you one more round of clarity. Here, if you look at this variable, how many copies exist? Just only one copy. It's not like objects. And this one copy can be shared by all other objects. I'll talk about it in a very detailed way. But one copy, at most one copy is there for these variables, for singleton variables, whereas these are separate for every object. That is one thing. Second thing, these methods can be called only by creating object, and these methods in singleton object can be called directly. You can call them directly. You can see here, remove this. And you can directly say m1 here, or if not m1, just for differentiation, you can take some x1. You can say x1 here. You can call it directly, no need of any object. And usually we can call it directly, just right click, run as Scala application. You can see how we here. Do I create any object here? Do I create any object here? No. Why? Because these are part of singleton objects, where these are global methods. You can call them directly within this object. Suppose I want to call it in another object. So I want to call it in this class. This method I want to call here in this class. How can I call? You can do it directly. But here I cannot just say something like m1. You cannot call like this. It's not possible. Okay. If I say m1, sorry, not m1, x1. If I say x1 here, you got an error here, compilation error, because x1 is present inside the singleton object test. So if I should call this, method or variable of a singleton object, within that object you can call anywhere directly. You don't need to call it with any other this thing. But you can also call the members of a singleton object outside that singleton object, even in some other classes. Then if I should call like that, then how do I call? I cannot directly call x1. It's not possible. Then there is another way here. These members are not instance members. These are global members. Means we can call them no doubt directly. But how? Outside the singleton object, we should call this variable or method or whatever what is present in this by using this object name. Means how do I call this x1 now here? I can say test.x1. That will work definitely. Got it right? So the error is removed. Got it? Now if you see, I am just making a call of this x1 from this m1 method. Now if you look at this output, you create this m1 I should call only by creating object. What should I do now? First you create object for a and then call m1. M1 will make a call to x1, then you get something. Got it right? Excuse me guys. Where some a equal to new a, then x dot a dot. So what is the output I am going to see here? What is that? Sorry, x dot. So what do I get now? Could you tell me what is the output I am going to get when I call m1 here? Answers, guys. When I call this m1, what do we see as output? That's my question. Okay, somebody is saying Vinod Krishna is saying that some answer. Others, how about others? All of you, please, can you give me your answers, guys? Just analyze and tell me. When I call m1, what output I get? It's 1020 and then howdy, or it's howdy 1020. Okay, or only 1020, or only howdy, like that. What's your answer? A runtime error, compilation error. This is how people give objective questions when you are going for any this certification exams. You get questions like that. The answer here is simple. When you call a method, the control directly goes from caller to the method, and it starts executing these statements. Now here, first we are printing A and B here, then the values of A and B printed then and there itself. After that, you are doing a call to X1. When you make a call to this, then the caller of this, again from here, this is a caller. Then what your compiler does, your JVM does, sorry, what your JVM, it will move the control from this caller X1 to the its corresponding function X, and then it prints howdy. Your answer is nothing but the 1020 and howdy. That's what you should see. Anyhow, let me run it. Can you see that 1020 howdy? Suppose if I declare this in the beginning, then it is howdy 1020. Suppose if I declare in the middle, then it is 10 howdy 20. See, you should understand the execution flow. You should have that knack of analyzing the execution flow. That is very important. So this is the idea about singleton. Is it clear now? So I have directly, started making you to understand with the concept, with the practical program, more than talking too much of theory here. But I just only give you a quick idea about the singleton pattern. What is it? At most, you can have only one object for singleton patterns. Okay, and then next one. And we know, usually another important point, no object is required to call methods or variables declared inside a singleton object. Okay, so then how to call members of a singleton object? Simple, right? It's object name dot variable name. It's something like this. Object name dot variable name. Okay, example test.a. Suppose if I want to call a method, it's just for calling variables. If I should call a method, how do I call it? Object name dot method name. Example test.m1. Can you see it? And also, if you want, you can make this methods also as parameterized. This can be parameterized. We'll do few use cases after this, sir. I'll give a couple of use cases to design a simple Pojo kind of class. That is one use case. Second use case is where in which scenarios we go for using this methods in singleton object or variables in singleton object. We do one more use case, the application of a use case, like the scenarios or the situations where we prefer to use singleton objects, so that you get that understanding, like when to apply classes, when to apply singleton objects. That gives you a clarity. Okay. Are you good now? Now, that's what I have done now. If you look at the syntax, how to call this singleton members just with object name. Whatever object name, using that object name, I am able to call this variable or call this method. But the point is, if I say object name, I am not saying reference here. Don't think reference. It's actually the singleton object name here. I am talking about this one, but not this one. I'm not talking about reference. I'm talking about the name of this singleton object. You should be very clear here. Don't get confused. My object name here is not reference, but it is nothing but name of object, that singleton object name. Got it? When we see here object name, many people thinks it as a reference, but my point is not linked to reference here. I think this is very clear. Now let's see these points. I told you all these things. I think most of this were discussed. In Scala, there is no static concept. Might be you might be little curious on this. Why this guy is talking too much about static? No, if you go to C++, Java, C#, even Python, even C language, sorry, it is there in even C also, that static keyword. The keyword static is there in all those languages. Okay, but in Scala, we don't have that. Usually static keyword in Java, I'll talk about with Java. It is used to declare something like, static variables and static methods. And these members, when you say something is static, a variable or a method, these are part of a class, not part of object. Object in sense, I have explained, like creating a diagram, the box and some variables inside that, and that is referring by some reference variable. I am talking about it. Instance variables exist inside object. Instance methods operate on object, but static variables, they don't have any object. Okay, they are common for all objects. They are like, a teacher in a class. You might have 100 students. A static variable is like a teacher. All 100 students, if you think them as 100 objects, they just share only this one teacher. That's what static variable is. Whereas instance variables are not like that, not like static variable. It's like, 100 students have 100 names. Yes, sir. Name variable is applicable for every student. Correct? Age is applicable for every student. Gender is applicable for every student. Means 100 names are required to talk about 100 students. 100 names are required, 100 ages are required, 100 genders are required. Means every student has some attributes, same attributes, but their own attributes. So in such case, what is that? We use instance variables to differentiate data from one object to another object. If data is common for all objects, then you have to make it as static. That static thing we do in Scala by declaring that in this singleton object. If you declare it here, only one copy is created for this and it is shared by all objects. I'll show you. I'll show an example after this. Do you get my point? We will practically do a workaround on that. No need to worry about it. We'll do workarounds. You know, right? We don't leave it like that. That's not our way of learning. Let's kill that topic. Okay. So just I get an idea, then we'll go for workarounds and let's understand it from the very practical front there. So if you look at it, there is no static concept here, but so Scala creates to compensate this. Instead of static, you don't need to worry. If you are a hardcore Java programmer, you don't need to feel that I am missing the static. You don't need to have that kind of sad thing. We have that static can be implemented with singleton object. So Scala creates what? Instead of static concept, it creates something called, we call it as a singleton object. That's what we use to provide, of course, the purpose of singleton. If you look at it, it is something which provides the entry point for your execution, program execution. Even in Java, you declare a test class. Inside that, you declare a main method, which is declared as a static in Java. Main method is static, public static void main. If you don't know about that, you can ignore it. I'm just giving you an idea. Here, singleton object acts as an entry point in which you always declare main. From the beginning, if you see, we used to always declare main method because this is the entry point for your program. Execution starts from main. It happens not only in Scala, but it starts from C, C++, Java, or most of these traditional languages follow the same, even Python also. Many people think that you don't have main in Python, but that is there. I don't want to talk more on that part. You got it right? That's the idea here. So what is the point? Let's conclude this. Do you think there is no static concept? Of course, there is no static concept, but we can replace that with singleton object. And the purpose here is singleton provides an entry point for your execution. Got it right? Another important thing, suppose, okay, you are coming with a debate. Suppose if I don't create this static, this singleton object, what happens? Then the answer for this is, what is that it's saying? If you don't create singleton object, you might compile your program successfully, but you cannot run it. What is it saying? But will not produce any output. You can compile code. Even in Java, you can run a program without main method. Means without main, you can compile the program, but you cannot run the program. Here also, if you don't declare singleton object, we can compile it, but we cannot run it. Because if you don't have a singleton object, then you don't have a main. If you don't have a main, then you cannot run the program. Do you get it then? Do you get this point? Understood? It's like what is that? Just for correlating, just to remember. If you think this as a car, this singleton object, and your main is like a steering. Okay. The point is, without these two, you might have all other parts. There is no use. You get my point? You don't have a steering, but everything is there. Engine is there, everything is there. Then what do you do, sir? Think about it. That's what means. You can still start a car, but you cannot drive it. Same thing here also. If you don't have singleton, still you can compile it, but you cannot run it. Correct? You agree? So that's it. So these are all conceptual. Why I try to insist or emphasize so much on these things is at somewhere at some level when you are working on some kind of code, these fundamentals are very very important to you. That's why I'm trying to give you that deeper insight for all this. Okay, and you can see here now another important point. Methods, you know all this. Methods declared inside singleton object are accessible globally. I think we have discussed this point. And also one more thing, a singleton object can extend classes and traits. Even inheritance is applicable for singleton objects. Inheritance is applicable for them as well. Traits thing we'll talk, nothing to worry. You get all this? So these are the important points you need to understand about singleton. Did you get this? Did you get this, guys? You got all this. Now let's do a workaround now on this singleton now. Use case. Suppose let's take a workaround and let's apply it. How it is, where it is applicable, and in what situations we need singleton methods. Okay. There are a couple of reasons here, no doubt. Without this, there is no entry point. For example, for our out of my curiosity, as I am a Java plus Scala plus Python developer, I have more doubts. What I thought is, for some time, I want to forget about this singleton. Okay. So what I'll do is just I'll comment all this. Let me comment this. It's commented over. Now you remove this. This is not necessary now. Remove this color. Have a program. Now I keep my main inside this, inside my class, assuming that can we have a class with main directly inside that? This is okay in Java. This is how a Java program look like. But this is Scala. Can we have a main directly in a class and can we run this program? Is it possible? That is what we are trying to see here. But when I bring that main into this class, I'm not seeing any compilation errors, but we should see if we run the code, are we going to have any compilation errors? For time being, instead of A, I'm changing the name of this class as test because this is saved with test itself, not to have that this thing. At the same time, let me create an object with test here because my class is test. I should create object for test so that the error will be removed. Correct, right? If your class name is test, you should create object for test, not for A, because I modified my class name. Correct? Okay. Now I brought this main into the class out of my curiosity, or you say foolishness. I want to test it like this, assuming that can we skip this singleton object in the Scala? But if it is Java, I'm for sure I can tell this will work, no doubt. Okay, right click, run as, and I am not able to find that run Scala itself first. Can you see here now? When I say run as, earlier we used to see all that run Scala application, but now it's asking run configuration. That itself is a proof we are missing out something. Anytime when you go to the run as and if you are seeing something like this, means what? Somewhere in the code you are missing out something that is not executable there. Suppose out of a, still I don't want to run it. Still I want to run. I just go to the run command here and just directly say run test just to make sure that to show my strength on this program. What I did do, what did I do now? I tried to run it forcefully. I had shown my strength. Then what happened? It is saying error, runtime error. Main method is not static in class test. Please define the main method as public static void main. But this public static void main is what? It is a Java style of declaring main method. It's asking to be like that. If you want to run it, make it as a Java kind of class. It is saying that. See, it is clearly saying what is that? If you want main to be in the class itself, okay, what this guy is saying, this compiler is saying, or the JVM is telling to us that if you want to run this program as a class, then where is it? Sorry, 1 minute. This one. It is asking to change the signature of main to what? Java main, not as Scala main. This is a Scala main. Suppose if I make it as something like this, let me try a Java main just for showing you. Okay, public static void main. This args colon array becomes a string args like this. It becomes like this. It's something like string args array. Save it and then remove this unit. Java will, it gets very irritated. Okay, Java don't like that. But I am seeing some error. What's an error? String args array. That's fine. But still, why error? Okay, this one. Delete this. Still, am I missing something here? Public static void main. Let me see. This is completely commented. String answer. Okay, I'll do one thing. Let me make it as the other way. Let me put it like this. Just only doing a workaround, guys. No, it's not allowing like this. It's not taking either taking Java style, or it's saying that it's not in a Java format. Okay, I tried to change to Java form. The signature of main, still it's not allowing me. Okay, expected. Okay, you can remove this, not an issue. Public static void main string args. Perfect, no issues. But in Java we create object like this. Class name space reference equal to new class name, but still not allowing. That itself, see, we don't need to again go too much into that. After some time, doing a bit of work around here, the errors are still there. That proves a point. What is that? This is not right way of declaring a Scala class. Point is, this main has to be the singleton object, and if you push it into the class in Scala, if you push main method to a class in Scala, it's showing some errors here. You can see here. That itself is a proof for us. This is not a right way of doing things, because this is a Java way, but we don't want to do it in a Java way. We have to do it in a Scala way. Then if it should be a Scala way, we have to declare this main inside a singleton object, not inside a class. Still, out of my this curiosity, right, this doesn't die quickly. This curiousness. Okay, I made this also as a Java variable, Java method. I make these variables also as Java variables. Like how? Instead of where here, this is how you declare. Just showing you quickly. Private int a equal to 20, private int b equal to 20. This is how we write a simple Java program. But still I'm seeing an error. Expected start of definition. It's expecting where, because this is which class? This is a Scala program. You can see the extension here is dot scale. Finally, after doing all this, I concluded one thing. I am going in a wrong direction. Let me turn back and get it into the right direction, because it's enough. Finally, the conclusion here is, what is that? Even you feel little tired now. You get, it's enough, sir. We got it. We got it. You might feel that also. We understood that this is not right way. We have to, what is that? We should not bring this main and keep in class and do something nonsense here. That you should be clear by now. What should I do then? Like a good boy, take the main to the which one? take main to singleton object. Okay, you got it right. So finally, I have done one more workaround, trying to put main in class and try to test it like in Java, but my attempt have failed miserably. But I learned something there. What is that? So it's like, we cannot declare directly a method in a class in Scala. Okay, so fine. Now leave about this class. I don't need class. We are doing a use case only on singleton objects. The problem is this. I'll give a problem to you. Sometimes, when you are working with this kind of languages like Java, like Scala, suppose I want to find sum of two numbers. Just a simple and no, I'm just taking a very simple and easiest use case. Okay, suppose, maybe to get more clarity for you, I'm taking a command prompt. Java.lang. Let me show you, because Scala can directly use libraries of Java unconditionally. And if you look at it, can you see this? These are all methods. Can you see here now? If you look at these methods carefully, you can see same method repeated for number of times. It's called overloading. I'll talk more when I move to overloading. The sign num is there for 2 times, but still they are not same. You can see some differences here. What is that? The parameter changes from one function to another function here. Can you see that? Can you see it? Even see, when you are going for such methods, you can see here all these methods are static. Can you see here now? In this math class, okay, I'm just giving you a better idea about coding, like when you should go for static, when you don't. These are very common and generic methods. These mathematical methods are used everywhere. When a method is very common, okay, when you don't depend on some objects, then such methods, if you look at this math class, almost all, if you look at it, 1 minute, let me give some power to this. Can you see that? Let me just scroll it little up. It permits. Majority of the methods in this class math, you can see static. Can you see that static there? Public static. These are static methods. Can you see that? You can see this. Majority of the methods are static. You might think, sir, you are teaching Java and suddenly you jump into Scala. What is the connection? Because Scala is nothing but developed from Java, and also most of the libraries of Java you can directly invoke in Scala. That's called interoperability. I told you somewhere. If you look at max function here, it's a static method, and you can see the advantage of having static methods is when something is common for common, which doesn't depend on object. Such kind of methods you can make them as a static methods. If we are implementing utility methods, utility means methods which don't depend on objects and which are common for all, in most of the cases. Most of the mathematical methods are utility methods, like sorting, searching, max, min, these scientific methods like tan, okay, cos, sine, all that. They don't depend on any object. They just need some inputs. It gives you some output. Such methods, you can declare it as static methods. Now we can rewrite the static methods in our Scala like this with the help of singleton object. I don't have a static concept, but I can implement same by using the singleton objects. If I declare such methods in the class, then they become static methods. It's a kind of static. I don't say direct static here, but it's a kind of static. And when should we go for such methods? When the methods are common for everything in the code, and which doesn't depend, and methods don't depend on objects, and such methods we can make them as static. Got it? Understood now, right? So I am very clear, like when should I use static? I have that understanding. Do you have that understanding now? I know as a developer when I should apply static and when I should prefer static, and when I should prefer instance. But many developers, even they don't know, they blindly take the things. But I'm asking you the question now. Are you clear now? When should you prefer static and when should you prefer instance? Is that clear for you? Okay. So when something is common for all objects, they don't belong to object. They are common to object. Suppose it's like this. I'll draw a small diagram to give you more insight on this. Okay. Suppose if you see here, set data and get data. Can you see here now? Set data and get data. They are, part of object. They are not. They are part means they are calling on reference of objects here. Okay. Let me show you how static methods are. Static methods don't depend on objects like this, and we never call static methods through reference of objects like s dot set data, s dot get data. And static methods, this instance methods operate on objects. They try to set data to an object, they try to get object data from object, or they implement some logic on this data of object. Such methods are instance methods. But a static method, in no way it is directly connected to objects, or they don't directly rely on data of objects. I don't say directly. Indirectly you can do something, that is a different story. Now suppose I have objects like this, something like object 1, object 2, okay, object 3, object 4. I have so many objects like this. Okay. Now all these objects have to use a common functionality. It doesn't change from object to object. Okay. The logic doesn't change from object to object. Like finding max of two numbers. However you do the max, the logic is same, and the parameters, input parameters, the number of parameters always same. Then suppose this is a max method. Let's just take it as max. See, this is common for all these objects. Logic doesn't change from object to object. Got it? Okay. Now these objects can share this. If you want, these objects can share these methods. We don't directly call them using reference, but you might use them somewhere in processing the data of objects. Okay. If you want, I can show you a use case like that also. But I'm just showing you a quick idea. These are common for the whole application, not just specific to any objects. The application itself, for the whole application, this is common logic. Okay, and this is common for all objects. All objects can share it, but they don't own it. There is a lot of difference. Instance methods are owned by objects, but static methods are not owned by objects. They are external to objects. Instances are internal to object. Objects might share static members, but instance members are inside each object. They are part of every object. Got it, right? That's how the difference is. So that is where you have to apply this static members. It is something which is common for the entire application. Got it, right? So now you do a small use case, no? Write a program. Maybe you can take sum, or you can take max. It's up to you. You want to take max, go for max. Write a program to find max of two numbers. Okay. And here what I need is, I need three methods of max. One method to find max of integers, another to find max of decimals. Okay, another to find max of float, otherwise max of integer numbers, max of float numbers, max of double numbers. I need three max programs, max methods inside this singleton. Okay, and then you can test them in the direct singleton itself. Okay, try this program. So when such methods which are common for the entire application, you declare them as a singleton methods. Okay, I'll just make a point of it. Singleton methods, these are global, we know, right? Singleton methods. We declare methods as singleton when it is common. That business logic, you can assume that business logic. When a business logic or any logic, if not business, is common for the entire application, not just a program, even for the entire project as well, entire application. That's all. Okay, and you can try this. If you declare in the singleton object itself, they become global methods and they are common for the entire application. You got it right? Try it. Finish it. Then tomorrow I'll talk about a few more use cases, and then I will also talk about POSO approach in Scala, how we can take setters and getters. Then I will switch to the case class. One more very beautiful topic in Scala. And everywhere, if you go to the Spark, you might see a lot of Scala classes implemented there. And in a Spark interview, trust me, in majority of the interviews, you don't find any interview without questions on case classes. That important that case class concept is. Finish it and post it, sir. Is it clear to all of you? So anybody is posting the answer? These are singleton methods. Usually such methods we can call them as generic, which is common. Generic means common. Is concept clear for all of you? Madhu, Vijay, Sri, Harish, Manoj. See, if you miss out anywhere, you can stop me. If even if the pace is a little fast, or if you miss if you miss something there, you can ask me to repeat. Don't hesitate. Please don't hesitate. Feel free to ask me to repeat or whatever is comfortable. Finish solving this problem. I'm waiting for your answers. Then I will stop the session. change here is we don't need to make it T1, T2, T3. You can make it as T only, because as parameter changes, still it will work. We don't have an issue. But still, even this is also fine. See, you are creating different singleton object methods. That is fine. But still, you can make it common as well. That name can be same also. This is also one good practice we can add. But it's good. I don't say you didn't go out of the way. It's perfect. And one more thing is you created an object again. The missing thing is I want them to be singleton methods, not like these are instance methods. Again, see, that is one more thing I'm seeing here. So the point is, it's not about talking about instance methods, but we are talking about singleton method. There is a lot of difference there. That is one more correction to the code. Same thing, just directly declare the this thing in the singleton object, and no need to create object. You can call them directly. That's the only difference. Okay, guys. I have other session at 11 o'clock. So what we do is we'll sign off here. Tomorrow I'll come and continue from here. Okay, I'll show you how to do this myself also, so that if you are missing anything, we can discuss there. Okay, thank you, guys. Good night.